Swayam Prabha. Digital India. Educated India.
Welcome to the last lecture on the data preparation module. So, we have been seeing about the data cleaning process. So, let us have some quick recap on what we have done in the previous lecture. We have detected some missing values in our data and we have imputed those missing values using many approaches. So, in this lecture we are going to see about some of the sampling methods. So, here we are going to discuss about simple random sampling and stratified sampling. So, in simple random sampling there are two methods which the sampling can be done, that is simple random sampling with replacement and without replacement. So, let us see one by one in detail. Let us first see about simple random sampling. So, in statistics, a simple random sample is a subset of individuals or nothing but the samples chosen from a larger set. Larger set is nothing but the population. So, here each individual is chosen randomly and entirely by chance, so that each individual will be having an equal probability of being selected as a sample at any stage during the sampling process. So, if that has been done, then this process or a technique is known as simple random sampling. So, if we draw a samples from a population which is entirely by a chance, by giving equal chances to all the individuals in a population, then we mean by simple random sampling. But this simple random sampling can be done in several ways. Simple random sampling without replacement, that is nothing but during the sampling, if the samples once chosen are not placed back in the population, then the technique is known as simple random sampling without replacement. So, that I will not have repeated samples in the sample values. So, that is commonly known as SRSWOR, which is the abbreviation of simple random sampling without replacement. Another technique is known as simple random sampling with replacement. That is nothing but if the chosen samples are placed back in the population, then the technique is known as simple random sampling with replacement. So, this is the difference between simple random sampling with replacement and without replacement. So, let us start with simple random sampling and the implementation in R. So, to do simple random sampling in R, we can use the command sample. Basically, sample is the function which takes a sample of the specified size from the elements of X. X is nothing but the population here. So, in the sample function itself, we can specify whether we are going to do the sampling with replacement or without replacement. So, let us have a quick look on what is the syntax of the sample. So, here is the function that is sample, and X is either a vector from which we are going to choose our sample. So, size is nothing but a non-negative integer which indicates the number of samples drawn from the population. Replace is equal to false means by default it will be false, which indicates replace indicates whether the sampling should be done without replacement or with replacement. By default, replace is equal to false means we are doing the sampling without any replacements. So, this is an overview of the sample function. So, let us see how to do that in R. So, first I am going to illustrate the sampling technique using a toy example, so that it will be easier for us to understand when we are going to work with a larger data set. So, first I am going to create a vector called X. How can I create a vector? So, vector called x. So, x is my vector name. So, to create a vector, I am combining the values from 1 to 10, that is I am just concatenating the values, that is from 1 to 10. So, when I try to print the x, I can have the values from 1 to 10, that is what I have created here. So, now I have a vector called x. How am I going to do the simple random sampling here? So, to do simple random sampling, we can use the command sample. So, we have two columns here, that is one for simple random sampling without replacement and another is for simple random sampling with replacement. So, here is the code and here is the output. So, to do simple random sampling, we have to use the function called sample. So, here this is the population from which I am going to sample out my samples, and this is the size of your sample. So, my population size is also 10 and my sample size is also 10 here. So, and I am naming it as SRSWOR, that represents simple random sampling without replacement. So, this is just a simple command where we are going to sample out some of the samples from the population x. So, when I try to print the samples, you can see the values, that is 10 values from the vector x. You cannot see any repeated values in the samples because we have done the without replacement technique. So, moving ahead, we will also see simple random sampling with replacement, that is described here as SRSWR. So, I have named it as SRSWR. So, I am going to use the same function, same vector, but I am going to increase my sample by one value, that is 11 here, because in simple random sampling with replacement, we can have sample size which is greater than your population size, because we are replacing our samples back to the population so that we can draw the same sample again. So, by giving replace is equal to true, I am doing the simple random sampling with replacement. So, when I try to print the SRSWR which contains the samples which has been done with replacement, it will have 11 values since the sample size is 11, which is greater than your population, that is 10, because you can see there are repeated values in your samples. 10 has been repeated twice, 8 has been repeated 4 times and 3 has been repeated twice. So, that it cannot have all the other values, but it can have the repeated values and it can have the set of values which is greater than your population size. So, this is how the simple random sampling with replacement and without replacement is being done using R. So, now we are going to use the simple random sampling in the churn data. Why are we going to use the simple random sampling in churn is, we are going to use the data churn and we are going to separate the data into train set and test set by using random sampling. Now, we are preparing the data for some analysis, right. So, in future we might build some model. So, in that case we usually build a model in train set and we will predict the model using an unseen data, that is the test data. For that we need to have two sets of data, one for modeling, one for predicting. So, that is why I am going to illustrate the train set, separating into train set and test set and how that can be separated using simple random sampling. So, this will be even more clear when we move ahead in future, but you can now take an example of how simple random sampling is being used in separating the data into train set and test set. So, to do simple random sampling, we can use the command sample, we know that. So, basically in I am using the function called sample. So, here I have specified 0.8 into number of rows of churn. What do we mean by that is, from the data churn I need all the rows, that is number of rows in churn, but I want 80% of the data as my sample. So, inside the sample function I have specified 80% of the whole churn data should be my ID. Why I have specified ID means, by doing this in my data I am just collecting my IDs, that is the sample IDs. So, 105 has been chosen as the first sample and 139th observation has been chosen as a second sample. So, now let us see how to get those observations as train set and test set. So, you have two columns here which displays train set and test set. So, from the churn I need all the columns, so that I am not specifying anything after the comma here, but I am specifying ID here. What do we mean that by that is, I mean all those IDs which should be as rows and with all other columns, so that it will become my train. So, now how much observation will be there in that? 80% of my churn data will be represented as train here. So, in the environment tab, if you can see, your train observation will have 200 observations with 21 variables. Ideally, before sampling it was 250 observations with 21 variables. So, now I have sampled out 80% of them and named it as train. So, now we have got the train set. How are we going to get the test set? So, in the same churn data, I do not need all those values which are in the ID, so that it will just have 50 observations, right. So, when you add 200 and 250, you will get the original data. Your 80% data will be in your train set and your 20% of your data will be in test set. So, by just giving the minus sign to it, I am excluding those observations from the ID and with rest of the observations, that is the 50 observations. So, what we have done here is, we have used the data called churn and we are trying to separate them into train set and test set using simple random sampling. So, here I have used the command called sample and 80% of my churn data will be as train set and rest of the 20% of the data, that is nothing but your 50 observations. So, this is how we separate our data into train set and test set. So, having done that, we can move ahead and look for understanding the characteristics of the sampled data. So, now we have sampled the data. How can we know that if the proportion of churn classes is similar across train set and test set after sampling? We can check that using. So, when I do proportion prop dot table, the inside the function you should have a table function, right. Table function is nothing but to calculate the frequencies under categories of churn. So, inside first we will look at the table function here. First I am getting the frequencies under each categories of churn, that will give us a number, but if I want to represent them in terms of proportions or percentage, I can use the command called prop dot table before that. So, by doing that, you can see proportion of your churn classes in the data frame train is this. So, we have about 31% of them who are churning in train set and we have about non-churners of 69% in the train set. So, let us see, this is the same case in our test set as well. So, to do that, instead of train I am using test here, so that I can get the proportion table of churn classes in the test set. So, it is pretty much closer to, because here we have 69%, here we have 68, this is 1% higher than the train. So, let us check, this is about the proportion. So, let us randomly pick one column and check if the mean is similar across the train set and test set. So, here I have chosen total charges. You can choose any numerical variable in your process. So, to calculate the mean of the total charges, I am giving the function as mean and the data frame I am interested in is train and the variable is total charges. To be on safer side, if there are any missing values also, I am excluding those missing values and calculating the mean. So, here is the mean of your total charges in the train set. So, people pay about 2275 rupees as total charges in the train set. So, let us see if this is the case, similar case in the test set as well. So, by replacing train by test, I will get the mean of the total charges in the test set. So, it is pretty much close, right? It is 2000 and odd, and it is also 2000 and odd. So, we have done a good sampling which is a representative of test, which is a good representative of the population, because we are having a similar trends in train and test as well. So, this is about simple random sampling. We have seen about a toy example to illustrate how simple random sampling has been done with replacement and without replacement, and we have also used the churn data to split the data into test and train, and we have also understood the characteristics of the sample data by checking the proportions across train and test, and we have also randomly picked a variable, and we have also checked the mean of the total charges across train and test. And we have came to know that the proportion and mean are more or less similar to the test set with compared to train set. So, now let us move on to stratified sampling. Stratified sampling is nothing but it is just a method of sampling which is similar to random sampling, but that involves a division of the whole population into smaller subgroups. Basically, if you have a population, when you are interested in sampling the subpopulation, or when you want to learn about the subpopulation, you will go for stratified sampling. So, here the population will be divided into small subgroups. Basically, if we have a population in Tamil Nadu, if we are concerned about sampling separately for male and female, then you should go for stratified sampling. So, smaller groups are nothing but the strata. So, each smaller groups will be represented as strata. So, in stratified random sampling or stratification, the strata are formed based on the members' shared attributes or characteristics. So, random samples are then selected from each stratum. So, this is nothing but simple random sampling is being done for each strata. So, that we will have samples from different groups. So, let us see how to do the stratified sampling using R. So, to do stratified sampling, we can use the function called create data partition. Basically, by doing create data partition, a series of test or training partitions are created by using this function. So, let us look at the syntax for using create data partition. So, here create data partition is the function, and y is nothing but your samples, vector of outcomes, samples to be chosen, and times is equal to 1, the number of partitions you want to create. By default, it will create only one partition, and p is equal to 0.05 is nothing but the percentage of data that you are going to use for a training set. List is equal to true means it is a logical argument whether the result should be presented in a format of list or not. By giving true, it will be represented in the form of list. So, this is an overview of the create data partition function. So, let us see how to implement that in R. To use the function create data partition, first we need to install the package called caret. We can use the function here. You can use install.packages. Inside the function, specify the package name within the double quotes, add another parameter called dependencies is equal to true, so that all those dependencies that are associated with the caret will also get downloaded. Having done that, you have installed the package called caret. Now, we have to load the library called caret using the library caret. When you use the function library of caret, you have loaded the package caret. So, now we are ready to use the create data partition function. So, to do stratified sampling, we know that we can use the command called create data partition. So, here since I need to specify some percentage in terms of p here, I am predefining my train percent as 0.8. So, that 80% of the samples will be as train. So, this is my train percent. So, create data partition is my command. I am going to save my sample or sample IDs to train ID, and from the churn I am going to sample based on the classes of churn. So, since we have two classes S or no, I am going to sample those observations based on S or no. and I am specifying my p is equal to train percent, that is nothing but 0.8, and list is equal to false since I am not going to represent my result in terms of list. So, by doing that, sample IDs has been saved, or sample IDs have been saved to a data frame called train ID. So, to get the train observations, you can use the similar method that we have done for simple random sampling, that is, use your data frame here and specify your train set sample IDs, that is train ID, and with I need all the columns, so that those rows in the train IDs will be selected with all other columns. So, this will be considered as train 1. So, this is about train set, right? What about the test set is, whatever those in the train IDs are not considered here, rest of them will be considered here, that is 20% of your data, churn data will be considered as test here. So, except those in the train ID, I need everything in terms of test. So, now we have used the carrot package, we have installed those packages and we have loaded them, and we have used the create data partition to get the stratified samples, and we have subsetted those IDs which is in the train ID as train set, and by excluding those IDs from the train IDs, we have got the test set. So, this is how your environment will look like after doing these two lines. Basically, your test set will have 49 observations with 21 variables, and train set will have 201 observations with 21 variables. So, let us try to understand the characteristics of the sampled data. So, similar to the simple random sampling, here also we can check the proportion of churn classes, whether that is similar across the train set and test set after sampling. So, similarly, I am using the prop dot table to check the if proportion of train 1 is similar to proportion of test 1. So, here your churn rate is about 69% of them are non-churners and 31% of them are churners, but here also you are getting the same with 1% higher than train 1, similar to the simple random sampling as well. Test proportion is not much deviating from your train 1. So, both of them have similar proportions. So, now similarly we can just randomly pick a column called total charges, and we will check if the mean of the total charges is similar across train set and test set. So, similar to the function we have explained before, you can get the mean of the total charges of train 1 using this command by checking the mean of the total charges in the test set. It is about 2942. So, basically your proportion is not changing, but your mean is drastically changing here. So, we have seen simple random sampling and stratified random sampling using churn data, where we have tried to separate the data into test and train, and we have also understood the characteristics of the sample data using by checking the proportion and also by checking the mean of a particular column in both simple random sampling and stratified random sampling. So, this is how we do simple random sampling and stratified random sampling in R. What are all the module outcomes? In the data preparation, what are all we have covered is, we have seen how to import the data from different formats. We have also joined those 3 data frames as one single data frames as churn using R, and we have also looked at the basic descriptive statistics of data, whether all those variables are with respective data type or not, and we have converted to valid data types if they are not. We have done some consistency checks, whether we have checked if the values are unique and if they follow any regular expression patterns or not. If they are not, we have also rectified them, and we have done some logical checks for outlier by detecting those outliers, and we have replaced those outliers by mean value of the particular column. And we have also encountered some of the missing values in our data in some columns, and we have also filled those missing values by using some measures like mean, median, and with maximum count for categorical variable. At last, we have seen about simple random sampling with replacement as well as without replacement, followed by stratified random sampling. So, these are all the module outcomes of the data preparation module.